So today I'm going to be talking about the continuity test. And the objective of this video is to figure out if x equals c, c being just any number, is continuous on f of x, just any function, right? So the continuity test is essentially 3 different steps, and you must pass each step, you must have each step be true before you can declare that at x equals c it is continuous, right? If at any point you fail one of the steps, you must declare that x equals c is not continuous, okay? So our first step is, it's kind of like almost like a checklist, right? I keep doing this, f of x, it's really f of c. Does f of c exist, right? So, suppose we had 2 graphs. We had one where there was a hole, and we had one where there was no hole. This is our point. Now, if you have something that has a hole, you fail this first step. This is not, let's say this is c. This is not continuous at x equals c. But this one, this graph, or this point here, it is continuous, right? You can draw this graph with one swoop. You don't have to pick up your pen and move it like this one. You would have to do this one, then skip over the hole, and then go here. So this passes our first step, our first sort of check on the checklist, right? Next, we have the second step. The second step is, does the limit as x approaches c of f of x exist? Okay? And essentially what this is saying is, does the limit as x approaches c from the left being the minus sign because over here all the numbers are negative, and limit as x approaches c from the positive side, the right side. That's how I like to remember it. Do these two equal each other, right? So now let's have that same sort of 2 graphs thing. Let's say this is c, and we have this graph, and we have this graph again. Now, this first graph would fail the second step of the continuity test because the limit as x approaches c from the left goes up here and it goes up into infinity, but it doesn't match up to the limit as x approaches c from the right, so fails. But here, these two limits approach the same points. Let's say this is 2. The limit from the left approaches 2 as it hits c, and the limit from the right approaches 2 as it hits c. Alright? I have a video on limits if you need a little brushing up on them. I'll link it here somewhere. Alright, and the third step is, does f of c equal the limit as x approaches c of f of x? Right? Now, essentially what this step is saying is, let's say we have, once again, that whole scenario. And let's say we have a point up here. Let's say that this is at 5, and this is at 3, and this is our c value. And now let's say we have a different graph where there's no hole. Our point is just right there, right where it should be at 3. Okay? So, you shouldn't, if you look at this first graph, you can see that our f of x is up here near 5. That's our y value. But then, your limit is where it approaches, right? So, the limit from the left is approaching 3, and the limit from the right is also approaching 3. So you would say the limit of c here is 3, right? It's not 5, because that's how limits work. So 5 does not equal 3, right? So this one would fail the third step, right? But with this graph over here, you can see that f of x is 3, and then the limit from the left and the limit from the right also approaches 3. So this graph would pass the continuity test, okay? So essentially, the continuity test is just a quick little checklist that you can use to figure out if x equals c is continuous on f of x. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!